Hello students, in this video lecture we'll start chemistry chapter 3. The name of the chapter is atoms and molecules. Student, before we start this lesson, recall what we have discussed in chapter 2. In chapter 2 we discussed about the matter. Matter was classified as a pure substance and impure substance. Student, we classified pure substance as an element and compound, and impure substance was classified as homogeneous mixtures and heterogeneous mixture. In this chapter, we'll be concerned only with the pure substance, that's element and compound. Student, elements and compounds are made up of the smallest particle. You know the smallest particle of the matter called atoms. Atoms. The smallest particle of a matter. Now when I say matter, it means elements. Elements. The smallest particle of a matter element is called an atom. Example: oxygen, nitrogen, sodium, aluminium, etc. etc. You pick any element and that element will be made up of infinite number of small particles called atoms. Say suppose oxygen is an element. If you pick oxygen, oxygen will be made up of atoms. If you pick sodium, sodium will be made up of infinite number of sodium atoms. If you pick element aluminium, that aluminium will be made up of infinite number of smallest particle called atoms. So student, atoms is the smallest particle of a matter, that's element. All the matter elements are made up of an atom. Atoms are extremely small in size. We know student, atoms are very small in size. Its size are measured in nanometers. Atoms are assumed to be spherical, and sphere have a radius. Sphere size is measured in terms of a radius. So atomic radius is measured in a unit called nanometer. Now student, next comes molecules. Now atoms and molecules are the smallest particle of a matter. Atom is the smallest particle of an element. Now molecule is the smallest particle of another pure substance called compound. The smallest particle of a matter, compound, is called molecule. Say water is a compound, carbon dioxide is a compound, ammonia, and many more. All these are the compounds. Think a glass of water. If we could look into the glass of water, we could see infinite number of particles. Now what is that particles? The water particles, the molecules. Think of a carbon dioxide gas collected in a container. If we could see inside the gas containing container, we could have seen infinite number of particles, carbon dioxide particles, carbon dioxide molecules. So student, if you pick the pure substance compounds, the compounds will be made up of infinite number of small particles called molecules. So water is a compound. Water is made up of water particles, that's water molecules. Carbon dioxide is a compound. Carbon dioxide is made of carbon dioxide particles. Ammonia is a compound. Now ammonia is made up of infinite number of ammonia particles, ammonia molecules. Now what's the difference between the atoms and molecules? Atoms are the individual particles, and molecules, when these individual particles, different individual particles combines chemically, what is formed is called a molecule. Say suppose water. Water is a compound. Now you can see in this water there are two different type of particles are there, hydrogen and oxygen. So hydrogen atom and oxygen atom means two atom of hydrogen and one atom of oxygen combined to make water molecule. So molecule, atoms combines to form a molecule. In case of a carbon dioxide, if you take suppose one carbon dioxide molecule, a particle of a carbon dioxide particle is made of three particles. One particle means one atom of a carbon and a two atom of oxygen, two particles of oxygen. Just like that, ammonia. If you pick one ammonia particle means one ammonia molecule that is made of four different particles. One particle means one atom of a sodium and a three atom of hydrogen. So that's the difference between atoms and molecules. So atom is the smallest particle of a matter element and molecule is the smallest particle of a matter compound. Now let's move on to another topic, student. That's the law of constant proportion. Now student, this is the law explaining the composition of a compound, pure substance. Now what is this constant means? Its constant is a fixed, proportion is a quantity. So it's a law of a fixed quantity. So what does this law says? It states in a chemical substance, the elements are always present in a definite proportion by mass. You take any substance, chemical substance, that chemical substance will always be composed of elements, and that elements will always be found in definite quantity, definite proportion by mass. Now let's take example to understand this. Suppose a pure substance, water. If we take water, the water will always be composed of hydrogen and oxygen. Now student, this water will always consist of two atoms of hydrogen and one atom of oxygen, irrespective of their source, the place, the person who collects it. Now what is the meaning of this? Say suppose water is collected from a tape. The tape water will always consist of two hydrogen and one oxygen atom. If I collect that same water from the river, river water will also consist of two atom of hydrogen and one atom of oxygen. If I collect that same water from suppose different place, say suppose water is collected from London. Now that water will always consist of two atoms of hydrogen and oxygen. That composition will not differ because of a place or because of the source or because of the person who collects it. That's what we mean by this law. That's the law of constant proportion. So in a chemical substance, the elements will always be present in a definite quantity by mass. So by extensive research and exhaustive study, this law was proposed by a scientist named Joseph L. Proust. So law of constant proportion was given by a scientist called Joseph L. Proust. Now student, let's move on to another term, that's atomic mass and molecular mass. Student, atoms and molecules, they are the smallest particles. Now if you pick atoms or molecules, definitely those particles will have a mass. So how to measure the mass of an atoms or a molecules? So atoms mass is called atomic mass and molecules mass is called a molecular mass. But student, this is not as simple as it sounds. Student, atomic mass, let's try and understand. The mass of an element, the mass of an atom, of an element measured with respect to the reference standard chosen for measuring atomic mass. Now what is the meaning of this, student? Reference standard chosen for measuring atomic mass means what? Reference and standard. Now if you go to shopkeeper's soap and if you ask something, say suppose 5 kg of sugar. Now to measure that 5 kg of sugar, the shopkeeper will be using the standard, a piece of iron which is hexagonal in shape, a three-dimensional iron piece. Standard, that's what standard. Standard mass may be 1 kg or suppose 2 kg or 5 kg or 10 kg masses. Just like that, in chemical science also, to measure the smallest particle, atomic mass and molecular mass, we have a standard. we choose a standard to measure the atomic mass. That's what we mean by this reference standard. Like shopkeepers are using that iron bar as a standard, 1 kg, 2 kg, 5 kg, 10 kg, just like that. Chemists also use a standard. So what is that standard called? We'll discuss a short while later. So we use a standard to measure the atomic mass. So if you measure the mass of an atom of an element using the reference standard chosen for atomic mass, that is called the atomic mass. So mass measured with respect to the reference standard chosen is called atomic mass. Same in case of a molecular mass, student. If you pick one molecule of a water, example, suppose you have a glass of water, you pick one molecule of water, that water molecule will have a mass. Now to measure this mass, we need the standard. So using a standard, if I measure the mass of a molecule of a water, that molecule's mass will be called a molecular mass. Now student, let's understand what is that standard, reference standard chosen for atomic mass or molecular mass is called. So standard reference chosen for measuring atomic and molecular mass is AMU. It's an acronym of atomic mass unit. Atomic mass unit, in short, is known as AMU, or small u, that's a unified mass, according to IUPAC, International Union of Pure and Applied Chemistry. That's an organization that decides all these units. So this AMU has been given a small name, unified mass, that's a U. Now student, what is the mass? AMU equivalent to gram. 1 AMU equals 1.99 into 10 raised to minus 23 gram. Now think about this number. This number is extremely small. So 1 AMU equals 1.99 into 10 raised to power minus 23 gram. Now let's understand, student. If I say atomic mass of oxygen is 16 unit, we will not say this is gram. So 16 U. Atomic mass of oxygen is equal to 16 gram. That's wrong. Atomic mass of oxygen is 16 U. Imagine one atom of oxygen. Can it be 16 gram? Not at all possible. Atomic mass of a 16 U. When I say so, what does it mean? It means one atom of oxygen is 16 times heavier than 1 AMU. Imagine a beam balance, physical balance. One side of the balance, one pan of the balance, you keep 1 AMU, that's a standard mass. Another pan of the balance, you keep on putting the oxygen atoms. Now to keep this balance same, say suppose we have this balance, these are the balance. Suppose here 1 AMU or let's say suppose this is 1 atom of oxygen. Now to keep this pan of the balance equal, we have to put the number of AMU this sides. Now to keep this pan balance, I have to put 16 units, 16 AMU. The moment I put the 16 AMU on this side of the balance, both this pan will be balanced. It means 1 atom of oxygen is 16 times heavier than 1 AMU. So that's what we mean by this atomic mass unit, and that's how we measure the atomic mass unit. Same in case of a water, in case of a compound, molecular masses. Say suppose I have a molecule of a water, H2O. Atomic mass of water is 18 unit. It means if I pick one molecule of water and if I put that one molecule of water here on this pan of the balance, now to keep this two pan of the balance equal or make it balance, I have to put 18 units, 18 AMU this side of the balance. So that's why we say atomic mass of water is 18 times or 18U, which means one molecule of water is 18 times heavier than 1 AMU. So student, I hope you understood what is the difference between atomic mass and molecular masses and how do we measure atomic and molecular masses. Now student, let's try and understand the calculation of a molecular masses. So from where we got this values of a water molecule's mass is a 18 unit. So we have a calculations. Suppose I want to calculate one molecule's mass, one molecule water's mass. So one molecule of water equals 1 into 2 plus 1 into 16. The sum is 18 unit. That's how we got the molecular mass of a water. Now what is this 1 here? So 1 is the atomic mass of hydrogen, and because we have a 2 atom of hydrogen multiplied by 2, plus this 1 means 1 atom of oxygen, and because oxygen mass, atomic mass is 16, so we have written 16 here. So if you simplify this, you'll get the sum as a 18 unit. Similarly, suppose if you want to calculate the molecular mass of a carbon dioxide, so one molecule of a carbon dioxide contains 1 atom of a carbon, so this 1 means 1 atom of a carbon, and because carbon's atomic mass is 12, so multiplied by 12 plus 2, this 2 means 2 atom of oxygen, and oxygen's atomic mass is 16, so multiplied by 16. So if you simplify this, you'll get the sum as 44 unit. So that's what the atomic and molecular mass, and that's how we calculate the atomic and molecular mass, student. So next lecture we'll be discussing the mole concepts. Okay student, thank you.